My pleasure now to introduce Malcolm Coral. So Malcolm is coming to us from Midwest Engineering and will be presenting to us on a new technology that we thought would be really good to share with you and some information about a product specifically, since they have some high energy efficient products specifically made for our climate here. So over to you, Malcolm.
Thanks, Tanya. So I believe I should have, there we go. For anyone who's not already familiar, ERV stands for Energy Recovery Ventilator. And what it does is it uses the warm exhaust air in a facility to heat the fresh outdoor air that we're bringing in from outside. So what that does is essentially provides free heating to that air without the use of, or reducing the use of the gas or electricity that we would normally need. And to give everybody a baseline of what we're comparing to when we talk about what the latest and greatest technology is, I'm going to quickly run through what the traditional technologies on the marketplace are today. So for small facilities, condos, single family homes, some small office type space, a sensible plate heat exchanger or enthalpy core is the most common type. And that's the image shown here in the middle. For larger airflow rates, commercial spaces like hospitals, schools, office towers, enthalpy wheel like what's on the right is going to be the most common. And for specialty applications where we have something harmful, corrosive, maybe toxic in the airstream, we're limited to runaround loops or heat pipes, which are what's shown on the left here. And these are all rated on two metrics, sensible effectiveness and latent effectiveness. And latent represents how much heat we're going to transfer, while latent represents how much moisture we're going to transfer. And while latent is very important to consider in any humidity controlled space, which most commercial buildings are, we're going to simplify the conversation a bit just by talking about sensible effectiveness. So I've listed some typical values here for technology that's found in the marketplace today. It does depend on the exact equipment. It depends on the manufacturer and the selection. But this is typical of what is both commercially available and financially viable. So what we can notice is that the highest we can get in terms of sensible effectiveness is about 75%. A good wheel selection can be around 80%, but it's quite difficult to get any higher than that without having impracticably massive equipment. So the other challenge here, we're a little slow to switch slides. I seem to have lost control. Could you switch slides for me there?
Perfect. I hear Pam clicking. There we go.
Thank you. So the issue with all of these technologies is in a cold climate like ours, they build up frost. And what happens is the air inside the building is relatively humid, either from us breathing, boiling water for coffee, or humidifying if we are providing humidification to the space. When that hits the cold heat exchanger, it condenses, freezes, and plugs it. So it can become inoperable if we don't do something to either periodically defrost it or mitigate that from happening altogether. And all of these defrost strategies reduce the effectiveness of our heat exchanger. So dual core technology was developed specifically to address this frost issue in cold climates. It is, I'm going to say, relatively new to Canada, and then we have a long way to go in terms of implementing it widely. But there are installations in Alberta. It was originally developed in Sweden and has long been in use there. And the construction is two aluminum cores, one on either side of this image shown with the plus and minus symbols, and a damper section in the middle. And the operation is, hang on while we wait for the next slide. The operation is that this damper section switches the direction of airflow every minute. So the exhaust air heats up one of these cores, the dampers switch, and now that core heats up the supply air. And because it's switching every minute, the warm exhaust is constantly being used to defrost either core. So you don't get any buildup of frost and you don't get any reduction in the effectiveness and energy recovery because it's an inherent part of the operation. So you can get up to 90% sensible effectiveness with these compared to the 75, 80% with anything else. So we'll compare here to look at specifically how much this frost mitigation impacts our effectiveness comparing to a wheel and a dual core heat exchanger. So look at a sample 10,000 CFM ERV unit, Calgary winter operation, minus 30 Celsius outdoor temperature. The most common way here to mitigate frost on a wheel is to use hydronic preheat. What that means is we just heat the outside air before it hits the heat exchanger to a point where it won't accumulate frost. Waiting for the next slide. So when you go through the analysis, we need to preheat the air to about minus 8 Celsius. And so while the wheel is 80% sensible effectiveness, and it still does, it's now only providing that 80% on the difference between minus 8 Celsius and the room temperature of about 20, 22. So it is technically still 80% effective. And if you run it on minus 30 degree outside air, it will provide 80% recovery until it builds with frost and plugs and stops working. So when you look at the real effectiveness, considering this preheat, you really only add about 47% compared to the 90% that the dual core unit maintains through any operation of the year. And these are rated down to minus 40. The other thing we can notice is that because we have this preheat, the required boiler capacity to provide that is about more than 5 times higher than we need for the dual core unit. So not only do we get more energy recovery by eliminating this defrost, but we can reduce the size of the boiler equipment, which also reduces the size of our piping, reduces the size of our pops. So that is the 6-minute summary of the technology. 4 minutes is not a lot for questions, and we have a full hour-long version of this presentation. So by all means, feel free to contact me after if anything remains.
Well done, welcome. This is definitely enough to hopefully wet everybody's whistle and get them asking lots of questions now and into the networking session as well. So does anybody have any questions right now for Malcolm?
I guess my one question, Malcolm, would be what's stopping people from jumping on this? Sounds like a really good technology to be using.
It's different, and what I'm trying to think of how to say this politely. It can be hard to get people to change.
You don't have to be polite if it's you don't want to.
I mean, well, one common thing too with a lot of these, especially in commercial applications, are driven by consulting engineers. And while there are lots and lots of good engineers in the city, they're largely motivated to price jobs based on low design hours. Low design hours means doing what they did last time.
Perfect.
So
that's a really good
sometimes a push
answer
from the owner to say, hey, I want something new. Yeah, it helps a lot.
You just described in one sentence the impetus as to why SSRIA started. So to really drive that change of innovation. So well done. This is why we're here. Is there any other questions for Malcolm? Perfect. Hearing none, we're going to go to our last presenter.